Hi, I am Warren and I am working with Dr. Starr and Dr. Haggerty this summer on the applications of motion tracking in temporally coherent echocardiography video segmentation. The goal of this project is to calculate global longitudinal strain and regional longitudinal strain so that we can discover and help doctors diagnose cardiomyopathies in patients. This is hard to do manually. We use a deep learning approach to automate this process instead. We start with a prior approach described in Chen et al.'s Class FV machine learning model, as seen here. We take in echocardiogram videos, specifically clips, couple frames of the video containing the end diastolic and the end systolic frames. It produces left ventricle segmentations and motion tracking information, which are vector fields as seen here. We can see the left ventricle segmentations here, and we do some image processing to get the myocardium lengths at the end diastolic and end systolic frames. We can see our motion tracking information has forward XY and backward XY movements for how the pixels move at each pixel in each frame. Down here, we can see the distributions of our strain values grouped by the ejection fraction of the patient. Green being normal ejection fraction, reds are high ejection fraction, and blues are low ejection fractions of the patient. Towards the right here, we have some outliers, but most of our data points fall around here, and these are negative values, which are anatomically correct as the length contracts, so we should see a negative percentage change. The normal ejection fraction distributions are the greatest, and we can see between them they are relatively the same. Now, quantitatively, we take a look at the global longitudinal strain. We compare the strain calculated from the ground truth label data to get the ED frame myocardium length and the ES frame myocardium length, and to get comparing against the warp data, we take the model's ED frame out and then warp it to the ES frame. We achieve a correlation of 0.540, and it is positive, but we can conclude that it is very low, and we have work to do in this area. So it has potential to calculate global longitudinal strain and regional longitudinal strain using our motion tracking information, but we have work to do, and we can conclude that it produces anatomically correct results.